Hi guys, today I'm reviewing the Pico 228 LED video light. I've bought 3 of these off of eBay. I've actually got 2 set up right now, so there's one right above us and there's one to the right as well. I bought 3 because I'm also going to put one to the left, and then that gives me really nice lighting for my workbench here. And also specifically for video and YouTube and those sort of things as well. So I'll do a separate video on this setup and how I've mounted these lights and everything. But in this video I want to do a review on these lights and sort of go through their performance and things like that. So this is the box. Like I said, I got these on eBay. I think they're about $35 each. So we've got 228 LEDs on each panel, 20 watts, 90-degree angle. They've got 50,000 hours LED longevity. Luminous flux or lux is 2,000 lumens. Color temperature is 6000 K, and color rendering index is greater than 85%. Now, some of these stats are need a little bit of explaining, but also the color temperature, for example, is adjustable on these things, and that's why I bought them, because you can go from warm to a blue white or a warm to a cool white with some dials on the side of the light module. Now, let's see what we got inside the box here. So I'll just take everything out first, I think. Okay, so inside the box we get the light itself. We get a tripod adapter to like a hot shoe or just a shoe mount on a camera. Looks like you can sort of change your angles and things. We also get a manual, which looks like it's bilingual, so we've got like Chinese and English. Yep, so it starts with Chinese and then we go into English. Just some basic sort of housekeeping rules and things like that. Oh, I should also note that these are designed to be used with a Sony type battery, the NP-F series. So you can use if you've got a Sony camera, which I don't anymore, but you can use the batteries from your Sony camera and plug them into the back of the light and use them directly. That's actually an issue for me, but because of the price of these lights, I decided to buy these and modify them, because I don't have these types of batteries and I'm going to be hardwiring them. So perhaps I'll show that in this video, but maybe in another video if not. But I'll explain that anyways. So you can sort of see they've got a battery indicator. They've got a switch and then 2 dials, one for the warm LEDs and one for the cool LEDs. So the specs say 7.5 volt, 20 watt, and we can go from 6000 to 3200 Kelvin. And this actually says 120-degree angle, so you can see what I'm saying about the stats in the box and in the manual, and you know what we're going to measure and things like that. They're a little bit loose, so I'm hoping that in this review I can sort of put all of that to bed and we'll figure out whether this is a decent product or not. So I'll just chuck this stuff over here. So you can see this is the light, and you might notice here that the LEDs, some of them are yellow, some of them are orange, and that'll be because the color temperature is different. So you've got cool white LEDs and warm white LEDs on the same module, and they've done a checkerboard pattern. So just quickly run over, that's where your battery plugs in. There's your indicator. We've got an on-off switch, and then we've got one dial is for warm and one dial is for cool. And then at the bottom we've got the tripod mount, so you could use this adapter and then put that on top of your camera and screw that down, and then that can sit on top of your video camera and obviously illuminate what you're filming. The way that I'm using these is with some adapter pieces. Actually, I'll show you that now. It's a bit crazy. I bought this off eBay and it's just a bunch of like GoPro adapters and things. And I've built an aluminium frame like I've done on my Workbench build, so you check out those videos to see how I build my shelving. And basically I've built the same sort of structure without the shelf, and I bolt this GoPro mount onto the aluminium frame, and then I can sort of attach the light and angle it and do that. So this is just like a whole bunch of GoPro mount pieces, and you know, they're a few bucks each off eBay. So here's the light itself. So what I might do is show you how this thing operates before I go into a teardown and have a look inside, because we'll do that as well. So over here, you can see I've got this power supply. So this is just a lab bench power supply. And on the other end of these banana leaves, I've got some alligator clips, because that will allow me just to plug straight into this. And from memory, the top is positive. So if I go like that, and the bottom is negative, and then we should be able to turn this thing on. So let me just turn on my power supply. Now these things run at 7.5 volts, 7.4, 7.5, anywhere around there is fine. But the nominal voltage is 7.5 volts in the spec. I think the batteries are usually around 7.4. And they say 20 watts. So let me just calculate that. So if we go 20 watt divided by 7.5, we're going to expect to see around 2.6 amps at its peak, potentially. So let's turn this thing on. There it is, straight away. So there's your switch. You can see we're only drawing very low. These are actually wound right down. So you can see immediately there's your two potentiometers, and it looks like that's our cool white, and this is our warm white. So by balancing these two, you can change the color temperature. I might just shine that down at the bench. You should see that's warm and that's cool. And these things go, like I'm only just winding them up a little bit, so if I go full way, you can sort of see that that's incredibly bright. And we can see we're also getting the 2.5 amps, so we're getting very close to that 20 watt rating, which is good. Yeah, these are impressively bright. They're very good. Yeah, they're really good. I mean, obviously you can see like how well this is lit right now on this bench, and I've got two running at about half intensity. So I could wind up a lot more, but I'm sort of just running at half at the moment. So that's basically how you operate it. Now the only thing is the color temperature, you're not really going to know what it is, because you've got to sort of wind it in and figure that out for yourself. But on most modern video cameras, like, you can do a white balance, especially if you've got a card like this. This is a white bowl card, but it's basically you got a calibrated 18% grey, and then you can shine a light on this, and using your camera you can calibrate the white balance so you get a perfect color temperature happening. So that's what I'll be doing with these lights, and I'll be doing it individually. So because when I do the white balance calibration with the camera, it'll give me the color temperature. So I'm going to set them all to about 4,300 Kelvin. That's sort of like my preferred color temperature. It's not too cool, but it's quite neutral. And that's how I'll set up the lights when I get it all happening. So I think what we'll do now is have a look and see like how wide the spread is on this thing. So what I might do is turn off the overhead lights, and we'll basically put this flat on the bench and see what the spread's like. That's probably going to be the easiest way to do that. Okay, so we've got the overhead lights off now, and I'm just going to hold this panel like this. Now if I turn up both lights at full intensity, you can sort of see the spread that we're getting, and it's probably closer to 90 degrees. If you look, you've got about 45 degrees. You do get some more out here, but it starts to go fairly dim. But in this sort of 90-degree angle, it looks fairly consistent. And I can tip that also on its end, and it's a similar sort of story. So I think 90 degrees is more accurate. I mean, 120 if you do take it right to its limits, but 90 degrees for a decent intensity for usable light, I would say. So I'll also mention that I've run some of these lights at half and full intensity for a while, just to sort of see how they went. And they do get a little bit warm up the top here, specifically over this side, and that must be where the constant current circuitry and the power circuitry all is. but it's not, you know, alarmingly warm or anything. It's still fine to hold and touch and everything. So it's not too bad. They're obviously using nice LEDs and it's quite efficient. So what I might do now is take the thing apart and we'll have a look and see what it looks like inside. Okay. So there's no screws or anything visible on the outside of these lights, and I have already pulled one apart just to have a look at how I'm going to wire it and things, and convert from this battery scheme into something that I can use hardwired. And I started with spudging tools, trying to sort of like unclip this seam across here. Turns out it's not clipped. It's actually got a bunch of screws. They're very sturdy and very well built. I was pretty impressed with that. So I'm going to show you how to take it apart. You do actually need a few bits and pieces, but really you just need some precision screwdrivers. And here's my little spudging kit, by the way. A bunch of little tools for getting into gadgets and electronics. But I just need a suction cap. So they've basically double-sided taped this front clear plastic lens sort of protective covering on top. And once we get that off, we can use our precision screwdrivers to take the rest of the thing apart. So we'll start doing that now. So basically what I do is I stick this in the corner because you want to start peeling from the corner. It makes it a lot easier. So I'll just stick that down. And this can be quite difficult, but you can see I've just peeled that corner up there. And we can peel the rest off carefully. Okay, so you can see there's a bunch of tape around the edge of that, and there's a little bit left on there, so you just got to sort of put it back the way it came off and it'll be fine. Looks like we've got most screws exposed. I'll just get a little, I'll use this little screwdriver here. There's a screw just here. I'll just remove that, that'll be fine. And there's also a screw up here. Yeah, up here. So I might just carefully just trim that. So we've got access to all these screws, and you can see we've got 8 screws to get into. So I'm going to use this screwdriver here, which is a 0x2 20mm. It's a number 0 Phillips. So I'm going to loosen all these screws, and I'm going to keep them where they are because there's no need to take them fully out. Some of these are quite tight. Jeez. All right. You can see how well this is built. Like they could have just clipped the whole thing together or just glued the thing together and been done with it, but they went to the trouble of designing it really well, and it's actually a really good move because you can see they've spaced these screws closer, and that's because you got your tripod mount there, so it makes it much more rigid. It's really good quality. I've been pretty happy with these lights. So we should be able to that screw there is a bit stubborn. There we go. So I can take that off. That's our front bezel. I'll just put that there carefully. It's still got all the screws captured in there. Now this is our main PCB. You see it's just a white PCB with these LEDs on it, and we've got 4 more screws. So I'll take those out now. Now these ones, it is actually best to remove them. I'll just put those over here, make sure I don't lose them. And we're in. So I can lift up this PCB carefully. It is attached with some power leads. And I can flip that over. There we go, Let me just get you zoomed in. So you can see all the traces there. If I get a reflection on that, you can see how they've traced out all these LEDs. And obviously they've got two separate circuits for the warm and the cool white LEDs, and they've done those in the checkerboard. So you can just see how they've traced that all the way around this PCB, double-sided. And then you can see on here, these battery terminals, which are sort of spring-loaded. If I can show you that. They are spring-loaded. And they come in to this side here. So I'll just remove this so we can see how that works. Basically what I've done in converting this to be hardwired, I've removed these terminals because they are captured in there, but you can just sort of like pull them straight out. I'm going to leave them there for now. And then what I did is I just desoldered the wires here, and I ran cables straight through those, wrapped it around here for some strain relief, and then I had the wires come out here. And then I put like a little DC jack on there. Another alternative would be to put the DC jack like along here, because there's plenty of space here. You could, if you get like a low profile DC jack, you could glue that in there, drill the hole and fix it there, and then run your wires to that or some other place. But I just went the lazy route, and because I'm going to have them mounted up here anyways, it's not going to get in the way. It's going to be quite fine. So that's basically what we got. And if you have a look at this board here, let me get a pointer. We'll run through some of these ICs and see what we got here. So it's going to be a little bit tricky. I've got to try and read what these are. Obviously we've got a bunch of tantalum capacitors here. We've got 100 microhenry inductors over here. We've got obviously our diodes. And basically, if you look at this, we've got like a power supply circuit here, and we've got a power supply circuit here, and they're identical. So this will be, you know, adjusting the cool or warm, whichever one it is. This is the adjustment for that circuit. This is the adjustment for that circuit, and here's our main sort of power switch. And you can see our positive comes off the battery, and it goes straight through the switch. So this kills power. So it's basically a direct connection to the battery, and you're not going to run your battery down. It's not like a soft switch or anything like that. And in here we've got, I'm just going to have a read of these chips. Just bear with me a moment. So this one here has LA8303JG LZC3. I'll put annotations on the screen if I can find any information about these chips. This one here is a NE555. That might be our 555 timer. So they might be doing a pulse width modulation, and that's just part of the 555 timer circuit to change its duty cycle or something. HYC 5J423. This one over here looks like a voltage regulator. It's a TI part. It's a LM339. So it looks like we've got our voltage regulator which serves our 555 timer circuits, which will be doing pulse width modulation or pulsing with a duty cycle to give us the different intensities on these LEDs. So it's quite decent. They're using decent parts by the looks of it. And it all looks pretty well put together. You can see a couple of crooked capacitors and things, but I mean that's no big deal. You can see actually this footprint looks like it was meant for an electrolytic, surface mount electrolytic, but they decided just to put the same tantalum capacitors in there. Maybe just reduce the BOM, a little bit cheaper, a little bit easier. Yeah, it seems to be working well despite that. And there's no markings on these LEDs that I can find. There might be something on the bottom, but yeah, nothing that I can read. There's no markings on the sides or the edges or anything. But it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 4, 8, 12, 16, 17, 18, 19. So I'm not going to do that on the top of my head, but 19 times by 12 is our 228. Well, thanks very much for watching. I hope you found that useful, and I can recommend these lights. I mean, they're not as cheap as some lights that you can find on eBay, but for 35 bucks, I bought 3 of them for just over $100. That's Australian, and they're brilliant. They're extremely bright. Being able to adjust the color balance is awesome. Yeah, and LED. The only thing is, if you want to hardwire them, you don't use a battery pack, you're going to have to do some hacking there, but I've shown you how to pull this thing apart. It's relatively simple and very easy to modify. So see you in the next video, guys. Cheers.